In chapter 10, we're going to start talking a lot about square roots, and the beginning of square roots is the Pythagorean theorem. Now, you've probably heard of the Pythagorean theorem. No doubt a man named Pythagoras came up with it, and we are just going to possibly do this when you come into class tomorrow. Scroll down and let's talk about the theorem. This man figured out that in any right triangle means you have a 90-degree, okay? In any right triangle, the sum of the squares of the legs is equal to the square of the length of the hypotenuse. Now you guys have to be able to identify the hypotenuse, okay? The hypotenuse is the tilted side, the slanted side. By definition, it's the side opposite the 90-degree angle, and we call it C. Now these two we call A and B. I really could care less which one's A and which one's B. Those are interchangeable, okay? So let's make sure you have a right angle. C is opposite the right angle. It's the longest side. It's the diagonal. A and B are what we call the legs. So what this says in algebra is that the sum of the squares of the legs, A squared, B squared, is equal to the square of the hypotenuse. And that's for any perfect right triangle. Now let's go ahead and try to apply this. The tiles at the right are squares with 6-inch sides. What is the length of the hypotenuse of the right triangle that's shown? So here's our right triangle. Do you see right here we have a right degree angle? So we can say that the legs are 6 and 6. Therefore, those are A and B. They want us to find the diagonal, which is the letter C. Let me make it a little darker. That's the diagonal. It's the hypotenuse, the letter C. So we take our formula, A squared plus B squared equals C squared. And we plug in A is 6 squared. B is also 6 squared. And C is who knows. 6 squared and 6 squared, that's 36 and 36, make 72. And now that equals C squared. It doesn't equal C. Take the square root. I'll actually let you use a decimal here. Pretty soon I'm going to teach you how to simplify that, but not quite yet. You're not there quite yet. You get 8.5 approximately. And it doesn't say what we need to round to, so we're going to round to the nearest tenth because it doesn't ask. 8.5 is the diagonal. Alright, let's try the got it. Now notice in problem 1 we are finding the hypotenuse, okay? The hypotenuse is the easiest one to find. Let's go to the got it. What is the length of the hypotenuse of a right triangle? Here's a right triangle. I'm a visual learner. I have to see it. There's my right triangle. It says the legs are 9 and 12. So just put them on there. That's A and B. So we got to find C. A squared, B squared, C squared. Now you could have wrote 12 and 9. Addition, you can rearrange, so it doesn't really matter. So 9 squared is 81, plus 12 squared is 144. You get 225 when you add them up. Okay, now you take the square root of 225 and you get 15. This one you don't even need to round. Let's put on our units. These are centimeters. Now you might ask, what do students usually forget? They forget to take the square root. Sometimes they'll answer that the answer is 225. Moving on to problem 2. Notice now we're going to find a leg. Well, it's not really that much harder. It's just one more step. Okay, and it's a subtraction step. So let's look at our problem. They're saying, hey, you're missing this side down here. They're calling it B. Okay, most important one, make sure you know that the hypotenuse is C. So we'll do A squared, 5 squared, plus B squared is B squared, equals C squared, 13 squared. Well, that's 25 plus B squared equals 169. Alright, now what you need to do is subtract, right? 169 minus 25 is 144. Look how nice that is. The square root of 144 is a nice pretty number, 12. When they work out really pretty like that, that's actually called a Pythagorean triple because there's no decimals and they're all real pretty numbers. So 5, 12, 13 is called a Pythagorean triple. Alright, let's try it again. Notice that now they're going to say, hey, you're missing the letter A. Okay, we can do that. A squared plus B squared equals C squared. Now which one to you guys is C? Hopefully we answered 15. So we got A squared plus 12 squared equals 15 squared. That's A squared plus 144. equals 15 squared, 225. It's going to be a good for you, by the way, if you guys can start learning these, your squares, especially for the next section. Okay, so you get subtract and you get a squared equals 81. And, excuse me, take the square root, a squared equals 9. This one doesn't have units, so we don't need to put them on. Now in problem 3, it says let's identify some right triangles. So that's not going to be a problem. It says which set of lengths could be the sides of a right triangle. So we have 6, 24, 25, 4, 8, 10, 10, 24, 26, 8, 15, 16. So it's multiple choice and it says which ones could be. This would be a pretty good keystone problem, I have to say. Now what do you think the most important thing to identify is in each one of them? I hope you said the letter C. You need to find the hypotenuse first. Now the C would always be the biggest one. So I'm going to circle that in each of my problems, circle the biggest one. And now let's check it out. We'll do 6 squared and 24 squared, and we need to see, I'll put a question mark above it, we need to see, does that equal 25 squared? Well, let's check it out. 6 squared plus 24 squared is 612. Well, that is certainly not 25 squared, because 25 squared is 625. This is a no. Alright, let's check out the next one. Let's see if it fits our formula. We'll do 4 squared plus 8 squared, and we need to see if that equals 10 squared. Well, 4 squared is 16, 8 squared is 64, and 10 squared is 100. Well, you tell me. I hope you know 16 and 64 does not make 100. This one does not work. Moving on. Boy, this is fun. 10 squared plus 24 squared equals 26 squared. Let's check it out. 10 squared is 100. 24 squared is 576. Alright, now let's see. What's 26 squared? It's 676. If you add those up, do they work? Put a big smiley face. That one is your right triangle. Option C is correct. Alright, let's move on and try it one more time. They're going to ask us, could the lengths of 20, 47, and 52 be the sides of a right triangle? 52 would have to be C, so let's check it out. 20 squared, 47 squared, and 52 squared. By the way, Mr. Ledbetter will be so happy if you know how to do these, because then it's a lesson he's not going to have to teach you. So we'll do 20 squared plus 47 squared, 2,609. 52 squared, hopefully you know that's not going to be odd. So 2,704, does that work? Nope. Explain. It doesn't fit the Pythagorean formula, Pythagorean theorem. Okay, reasoning. If A, B, and C satisfy the Pythagorean theorem equation, are 2A, 2B, and 2C also possible side lengths of a right triangle? How do you know? Well, I think you guys, since we're in the honors class, I think I can probably show you something here. Let's do this. Let's do 2A, quantity squared, plus 2B, quantity squared, equals 2C, quantity squared. Ready to check it out? Well, that's going to be 4A squared, because 2 squared and A squared, plus 4B squared, because 2 squared and B squared, equals 4C squared, because 2 squared and 2 squared. Now look at this. Divide everything by a 4. Look how everything cancels out. All those 4's go away. Guess what you get? You get the original Pythagorean theorem. Is it true? Absolutely. It will always work, as long as you double all the sides. So you might be like, Miss Linda, what the heck are you talking about? Guys, 3 squared, 4 squared, and equals 5 squared. Okay, so it's 9 plus 16. That is a Pythagorean triangle. Now what they're asking is if you doubled it. That's what they mean by 2 times it. Would it still work? Well, yeah, because 36 and 84 equals 10. So does it work? Absolutely. You can multiply them by any amount as long as you multiply them by the same amount each time. Now, I know I attached this section to 10.1, but instead of doing this section, we're going to wait for it. We're going to do this on over the weekend, and we're going to have a project tomorrow when you come in with a Pythagorean theorem. All right, have a good night.